Imagine you are the proud parent of a brand new baby girl. You bring her home and you start to notice that something isn't right. She isn't moving well and is having trouble swallowing. You take her to the doctor and they diagnose her with spinal muscular atrophy, or SMA. Today we'd like to teach you more about spinal muscular atrophy.
So SMA is a neurodegenerative disorder. It is primarily affecting newborns and infants. So in this disease, what happens is affecting cells that are called motor neurons. These are the nerve cells that contact and are able to drive the contraction of muscles. So in the disease, these cells, these motor neurons die, they degenerate, and then as a consequence, the muscle undergoes atrophy. The result of this is that infants and patients affected by the disease lose their ability of moving and also swallowing and breathing. And unfortunately, in the most severe cases and also the most frequent of case of SMA, this is a lethal disorder and essentially leads to death within the first years of age.
So there are 4 different kinds of SMA in human beings. The most severe is known as type 1, which develops before 6 months of the birth, and in that case the patients are unable to sit properly. In type 2 SMA, it develops between date of birth to 18 months of age, and in that case the patients are able to sit but can't walk independently. In the third case, that is mild form, it develops up to after 18 months of birth, and in that case the patients can walk with some assistance. And the fourth one is the mildest form. In that it develops in the elder age, or you can say after 30 years of age, and that is very mild.
SMA is a disease that it has a big gradient. So the most common in humans is the type 1, which is the most severe. The large majority of the babies born with SMA are of the type 1, which means that when they are born, they do not have any reflexes. They used to be known prior to identification of the gene as the floppy infant syndrome because they don't have any reflexes, any tone. These babies, they have to be intubated and they succumb approximately by the end of their first year.
You know your child is sick and you go online to find out more. A quick Google search will find you an organization called Cure SMA that helps with fundraising, medical outreach, and drug development for families affected by SMA. Established in 1984, Cure SMA has grown to include over 24 chapters and around 5,000 member families. On March 18th, several runners ran the New York Half Marathon for Cure SMA to raise money and awareness. We asked them to share their personal stories.
I ran the marathon, and the half marathon actually, in honor of my son Javier Brooks, who passed away in September of 2014 from type 1 spinal muscular atrophy. Shortly after his passing, I became involved with an organization called Cure SMA. And as you know, they're involved in the research for a cure and also outreach to families who have children affected by the condition. He was diagnosed at the 5-month mark. Before there, no one could figure out what was wrong with him. So we went through a lot of testing, and it wasn't until we went to a neurologist that they were able to pinpoint the diagnosis and then send us to a geneticist who was able to verify for sure that this is what he had. From that point on, I had 3 months to spend with him. We decided that we were not going to do a tracheotomy and life support, and so I spent the time that I had with him And it was after his passing that I became involved with Cure SMA. So I found Cure SMA online, and they helped me set up a memorial kind of donation site after his passing. And from there, they contacted me a couple months later and said, you know, we'd really like to have someone with your background. I'm a lawyer, a finance lawyer, on our finance committee. Would you like to join?
I was the oldest of three brothers. My mom had my younger brother, Robert, in 1973. He passed away from Wernicke-Hoffmann's disease, which is type 1 SMA. And then in 1975, my other brother, Jonathan, was also diagnosed at birth with type 1 SMA. It was a little bit more aggressive. He passed away in about 4 months. For me, I felt like I was a ticking time bomb because type 4, you know, that only shows beginnings of symptoms in your 30s. So when you have two brothers that pass type 1, the first thing you think about is, well, there are 4 types. Oh, good, I didn't get type 2 or 3. That's great. And, you know, at the time, I knew just enough to be dangerous, like I was telling you, right? So, you know, I don't know much about the disease as far as the recessive gene and you know, the real medical stuff. But the bottom line was they told me, yeah, you can get type 4 and it starts showing symptoms in your 30s. And that's what your doctor tells you. So the next thing you know, it's like, oh, brother, talking, you know, you're a ticking time bomb. So
Human DNA is the guide our body uses to make all of its cells and proteins. In order to make proteins, DNA is copied into RNA, which is the blueprint to make those proteins. In a child with SMA, there is a mutation in DNA which shuts off a gene called SMN1. This mutation causes a protein called a survival motor neuron, or SMN, to fold incorrectly, making it unusable by the body. The body depends on good SMN to ensure our motor neurons stay healthy, so if this protein is mutated, the neurons will be unable to survive. Without motor neurons, a person will not be able to control muscle movements for walking, breathing, or swallowing.
This actually has also provided an opportunity for the therapies or for the treatment for this disease that are upcoming in the clinics, because correction of this RNA deficit directly by really harnessing with the biology of the RNA and actually using little molecules, little fragments of RNA that will bind the endogenous SMN gene, or even drugs that have been developed by pharmaceutical companies to indeed correct this splicing, this RNA processing event that is defective in the disease, are used as a way to increase the level of SMN in patients. So essentially by tweaking the RNA processing of the SMN gene, we are now able to increase the level of the protein and provide a benefit to the patient.
What we're very excited, we have identified a mechanism recently where the remaining and the surviving motor neurons in the disease, we will be able to make them work better, as close as to their control motor neurons. Recent work from our lab, as well as other labs, has explored a completely different line of research. That is that SMA is not only affecting NMJs, the neuromuscular junctions, not only motor neurons, which are the responsible neurons making that contact with the muscles, but also other neurons in the central nervous system, and particularly in the spinal cord. So the point of the focus of our lab is to explore two different questions. In neurodegenerative diseases, including SMA, there are two major things that are happening. Certain neurons die, and the other neurons dysfunction. What is the importance of this balance? How many neurons we can afford to lose, and the rest of the neurons that they remain there, that they're sick, how we first of all identify what are the causes of their dysfunction and how we can reverse it.